We've already looked at how to find the volume of a pyramid, a cone, and a sphere. And we're now going to have a look at how we can find the surface area. Now remember that the surface area of a shape is the area of the outside. How much paper would I need to actually cover the outside of this shape? The whole of the outside, including the bottom. This is what we're looking at. Okay, so let's start off with a pyramid. We've already seen three-dimensional shapes when we were looking at trigonometry and Pythagoras in 3 dimensions. So we should be able to think three-dimensionally for this. So we're finding the area of the outside. Here we have a square-based pyramid like the one I have here, basically. Remember, it could be triangular-based, it could be rectangular-based. This one here is a square-based pyramid. So we have this base on the bottom, which is square, and we have 4 sides around it, which are all isosceles triangles, and they are the same isosceles triangle because they all have a base of 7, as that is a square underneath. Okay, so let's first have a look at the area of, how do I find the area of one of these sides? To find the area of one of these sides, I'm going to have to do the base times the height over 2, which is basically the area of a triangle. But looking at this triangle, we don't really have the height. What we do have here, is that the slant height or is that parallel to here? How they given? I think this is. So this 10 centimeters here must be the slant height here. It's not this height here, because you can see it's telling me from here all the way down to here. It's showing me these lines that this here is 10 centimeters. Okay, so if I take this triangle here, for which we have 4 of, if I just take that out of there so that I can see it, I'll draw it here. It's a right angle triangle, and across here is 10 centimeters. And the whole of the bottom there is 7, because it's a square-based pyramid. So they're talking about the whole of this is 7 and the whole of this is 7, which means that this part here must be 3.5. Okay, and I'm trying to find the height of this triangle here. I'll just call it X for now. I could call it H if I liked. Okay, so I'm trying to find that height. I'm going to use Pythagoras theorem, obviously. X squared plus 3.5 squared equals 10 squared. So X squared equals 10 squared minus 3.5 squared, which is 87.75. So I need to square root 87.75, so I get rid of the square there as well at the same time. And that is not going to come to such a wonderful number, so I'm going to leave it as that, as it's not a final answer, and I'm going to use it later on. Okay, so now I need to find the area of this triangle, the whole isosceles triangle. I have 4 of them all the way around, as I already said. So the area of the 4 sides, or the 4 triangles, equals 4 times base times height over 2. So 4 times, well, the base of the triangle is 7, and the height, which is this here, I just found it here, which is the square root of 87.75 over 2. And you will find that if you put that in your calculator, it will come to 21 root 39, which as a decimal is 131.144958. Okay, so the area of the base now below, because we don't just want all the sides around, we also want the base underneath so that we can make up the total surface area. So the area of the base is a square equals 7 times 7, or 7 squared, 49 centimeters squared. So we have these 2 answers, which we need to add together. So we'll add the 21 root 39, which is my accurate answer, plus the 49. I'll add them together, so the total surface area equals 21 root 39 plus 49, which will come to 180.145, or to 3 significant figures, that would be 180 centimeters squared is my final answer. And that's it for that one. Okay, now let's look at another example here. In this case, we have a triangular based prism, and we can see that all these sides are the same. So we have a triangle on the bottom, a triangle on the side, a triangle, 3 triangles around the outside, because it's 3 sides at the base. So altogether I have 4 triangles. And we need to find the area of these. Well, they're not really isosceles, are they? They are equilateral this time because all the sides are equal. So imagine I have equilateral triangles, each of size 6. And let's just take one side because we need base times height here, divide by 2. So I need to find this height here, basically. Let's just redraw this, okay, into a right angle triangle so we can work with that. This is 6. Down here will not be 6 because it's all the way is 6, which means we have half of that, which is 3. And we're looking for this, I'll call it H because they've called it H on the diagram as well. All right, so if I sum the square of the 2 perpendicular sides, H squared plus 3 squared, I will come to the hypotenuse squared. So H squared equals the hypotenuse squared minus 3 squared, which will come to 27. 36 minus 9 is 27, so the square root of 27. So the total surface area, in this case, are 4 of those triangles. So it's 4, because we have 3 around the outside and 1 at the base. So 4 times base times height over 2. So 4 times the base of the triangle, in each case, is 6. So 6 times the height over 2. We put that in our calculator. We should come to, what will we come to? 2 times 6. Okay, I cancelled these in my mind. I said 2, 2, 6 is 12. So it's 12 root 27. In your calculator, we'll simplify that 27 as well, because there is a root 9 in there. 9 times 3 makes 27. And your final answer will come to 36 root 3. If I put that in decimal form, 62.354 or 62.4 centimeters squared is my total surface area. And let's look at another pyramid. So we saw a pyramid where we have the slant height, we have a square base, and we have the base of each triangle here. We now look at this pyramid here, where we can see is again a square base pyramid. But here we have a vertical height. We don't have the slant height. We don't have the height of the triangle here either. Okay, so these are 2 different heights. This is a slant height. This is the height of the triangular side. We don't have that. We have the perpendicular height of the pyramid. So we have, if I take perpendicularly here, how tall is the pyramid? So, which would be useful actually if we were finding the volume. Do you remember finding the volume of a pyramid? You just find 1/3 of the base area times the perpendicular height. But in this case, we're finding surface area. We're not finding volume. So we really need to know, we really need to know this side here, this height here, the height of a triangle. So if I actually put that height inside the triangle so I can see it, and I drop it to the middle, and then I go across here, this here will form a right angle triangle. Okay, where this is 7 centimeters, this height here. This across here will be half of all the way across. This is actually parallel to this here, which means that this here must be half of the size of this here. So this is a 2, which means, again, using Pythagoras theorem and our logic, we can find this hypotenuse here. They've called it L. Okay, so in this case, I'm going to say L squared equals the hypotenuse basically squared, equals 7 squared plus 2 squared, which we know is 49, and 4, which is 53. So my L equals the square root of 53, which is not going to be pretty, so I'll just leave it as it is for now. So I know that this here is square root of 53. So to find the area of this triangle here, I'll just draw the triangular side so we can picture it. Okay, we have 4 on the base, and we have a height here of square root of 53. And I have 4 of those triangles. So the area of the 4 sides, or triangular sides, or 4 triangles is fine, equals 4 times base times height over 2, which is 4 times the base is 4, and the height is square root of 53 over 2, which will be 8 square root of 53. That's my accurate answer. If I put that in my calculator and I really wanted a decimal answer, it would be this. The area of the base, which is a square, is 4 times 4, 16 centimeters squared. I add these together to get my total surface area, and I will end up with 74.2409. Round it to 3 significant figures, 74.2 centimeters squared. There we have it. And we'll start looking at the sphere now. What is the surface area of a sphere? The surface area of a sphere is given by the formula 4 pi r squared. Okay, a sphere has a radius. We've seen this before. Just like any circular shape will have a radius. This will go all the way up, around, could be anywhere. We'll have a diameter. Okay, a tennis ball has diameter of 8.4 centimeters. So we're talking about all the way across, or all the way across from any direction, just going through the center, is 8.4 centimeters, which means that the radius must be half of that. So radius equals 8.4 over 2, which is 4.2 centimeters. So if I want to find the surface area, then the total surface area equals 4 pi r squared. I just need to plug into that formula. Four times 4.2 squared. If you put that in your calculator, we'll come to 70.56 pi. Okay, which is 221.670, or to 3 significant figures, 1, 2, 3, is 222 centimeters squared. Cool. We've already spoken about the hemisphere. Hemisphere is half of a sphere, so we've cut the sphere in half. So half the tennis ball, we would say, is a hemisphere. Okay, we've already spoken about it when we did volume. Now we're talking about the surface area. The difference between volume and surface area is that with volume, we just literally measure half of the volume would be the volume of a hemisphere. But you have to be careful when we're talking about surface area, because we're talking about the area of the whole of the outside. So we're talking about half of the area of the whole sphere, half of the area of the outside, to get the curved surface area, but we also need the area of the base here, because this is also on the outside, so you need this circular bit in as well as part of the surface area. So a paper weight is in the shape of a hemisphere. It has a radius of 25 millimeters. Find, given your answer to the nearest whole unit, its surface area. So we're going to split it into 2 parts. We need the area, the curved surface area, which is this formula that we have here, but divided by 2, so we don't want the whole of this. So We want the curved surface area plus this circular bit here on the bottom. So the area of the curved surface, or the curved surface area, equals a half of area of sphere. So it's a half of 4 pi r squared, which equals a half times 4 pi. The radius we said was 25 millimeters. Put that all on in your calculator and you will get 1,250 pi. Okay, we then need to add, we have this outside bit of this here, the curved surface. We now need to add that circle in. So the area of the base, we'll call it circular base, equals pi r squared, which is pi times 25 squared, which will come to 625 pi. And we now need to find the total area of the outside, which is both of these together. So the total surface area of the paper weight is 1,250 pi plus 625 pi, which is 1,875 pi. So that's 5,890 millimeters squared to the nearest whole number. Okay, moving on to example 6. Here we're given the surface area of a sphere. So the surface area of a sphere is 616 centimeters squared. The surface area of a sphere, we have a formula for that, is 4 pi r squared. So 4 pi r squared equals 616. So we're trying to work out the radius here. So r squared equals 616. Let's take the 4 pi underneath because it's multiplied over here. It goes under. So that implies that r must equal the square root of 616 over that 4 pi. And that will come to 7.0014. Okay, to 3 significant figures, since they haven't told me, it's 7.00. If they tell you to the nearest whole number, you will say 7 centimeters. If they tell you to one decimal place, you will say 7.0. Okay, they haven't told me anything here, so I will just do it to 3 significant figures, as I always do when they do not specify. 7.00. Okay. And lastly, we will have a look at the cone. Okay, now,